Hello, welcome. My name is Mr. Tompkins, and today we're going to talk about how to convert a position versus time graph into a velocity versus time graph. After this, we're going to talk about how to calculate an object's average velocity. There's two ways to convert a position versus time graph to a velocity versus time graph. The first way is the way that I'm going to show you right now, is going to involve obtaining ordered pairs, or an x value and a y value, in order to plot my velocity versus time graph. My position versus time graph is given over here on the left. The object travels in the positive direction at a constant velocity. I know it's constant because the graph is linear, or it's a straight line. So really what I have to do is I have to pick 2 points and calculate the slope, because we know that slope equals speed. So if I look at my line here, I notice that it goes through 0, 0, which is down here on the bottom, and it also goes through 4, 4. So I'm going to use those to calculate my slope. Now the first thing to do when calculating slope is to calculate the rise. If I were to look here at the rise, it starts at 0 and it goes up to 4, and it's represented by this red arrow. Now, if I look at this, my rise, because I go from 0 to 4, is going to be 4 is the number, and then the units are going to be meters. The next thing I want to do is I want to look at, well, what's my run? My run is going to be shown by this green arrow. It starts here at 0 seconds and goes to 4 seconds. So my run, numerically, is going to be 4, and the units are going to be seconds. If I were to calculate my slope as rise over run, well, my rise is 4 meters, and my run is 4 seconds. So if I simplify this, I get 1 meter per second. Now, because this is a line, I know that the slope of this line is going to be constant throughout the whole situation, or the whole scenario. So at time equal to 1 second, I'm going to be traveling at 1 meter per second. At time equal to 2 seconds, I'm going to be traveling at 1 meter per second, because the slope hasn't changed. And at time equal to 3 seconds, I know I'm going to be traveling at 1 meter per second. Now that I have these ordered pairs, I can plot my graph. So at 1 second, which is here, I'm traveling at 1 meter per second. At 2 seconds, which is located right here, I'm traveling at 1 meter per second. And at 3 seconds, I'll be traveling at 1 meter per second also. And so if I look at this and I were to draw my line, my velocity versus time graph would look like this throughout the whole 4 seconds. It is a straight line, a constant velocity. And so I see that my position versus time graph converts into a velocity versus time graph that looks like this. Okay, so now let's look at the other way. The other way is easier, but it involves me having to line up my 2 graphs. The first thing I want to do whenever I have these 2 graphs, and I want to do this qualitatively or without numbers, is I'm going to line them up vertically. And then I'm going to draw lines down to show how these 2 scenarios will play out. So there's the first section. Here's the second section. And then the third section's over here. Now I have to look at these sections individually and predict what the velocity is going to be. So let's do that. Here I have a positive constant velocity that is somewhat fast. All right. Above my 0 line here on my velocity versus time graph is going to be my positive values, or my positive velocities. And since my slope up here is positive, I know that it's going to be positive. If I look here on my position versus time graph, well, it has a 0 slope, which means my velocity is going to be 0. And then if I look over here in the third section, I see that my velocity is negative because it has a negative slope. It is constant because it's a straight line. And I know it's somewhat slower than the first one. So the first one was at 1.5 meters per second is what I guessed. The second one was at 0, and then the third one's going to be less than 1.5. So let's say that it's 1 meter per second. All right, and it's negative. So my graph, if I look at it, let's go ahead and get rid of these. Looks like that. So I have this fast positive speed, a 0 speed, and then a negative velocity down here. And so that's how we're going to convert between position versus time and velocity versus time graph. Now I want to talk about this concept called average speed. If I look at this, the average speed is the uniform speed an object would need to maintain or to cover the same distance in the same amount of time. So let me re-say that. The average speed is the uniform speed or the constant speed that an object would need to maintain to cover the same distance in the same amount of time. So here I have a scenario. I have an object that travels at 8 meters per second for 20 seconds, and then it starts to travel at 12 meters per second for 5 seconds. Now, the average speed is not obtained by averaging the two speeds in the normal way. In other words, if I were to take any two numbers and average them, well, I would take the two numbers, 8 plus 12, which gives me 20, and then I would divide by the total speed. So here I have 8 and I have 12, so there's one speed, two speeds, and so that's 2, and so that comes out to be 10 meters per second. This is not correct. I will see this. Please don't do this. It is not an accurate way of doing this, and you're going to get the wrong answer. Instead, we must determine the distance the object traveled. Notice I said distance and not displacement, so we want absolute values. We want all positive numbers. So in the first instance, the object travels at 8 meters per second for 20 seconds. Now we learned before that distance or displacement equals v delta t. And so in this first part, went 8 meters per second for 20 seconds, it's going to be 8 meters per second times 20 seconds, which gives me 80 meters. I'm sorry, excuse me. Let's redo that. 8 meters per second times 20 seconds is going to give me 160 meters. 8 times 20, 160 meters. Now for this last part, I have 12 meters per second times 5 seconds, and that's going to give me 60 meters. So now, if I look at the total distance the object traveled, well, it went 160 meters, and then it went 60 meters. So that's going to be, if I add those two together, I get 220 meters. So that's the total distance my object traveled. The next thing I need to do is I need to determine the total time it took to travel that distance. So it went 20 seconds, and then it went 5 seconds. So 20 plus 5 is 25 seconds. So that's the total time it took to travel that 220 meters. Then we're going to use the speed equation to determine the average speed. Now the speed equation we used up here before, all right, except I converted it into another version. But the speed equation or the velocity equation equals my total distance, my delta x divided by delta t. So in this case, I have 220 meters divided by 25 seconds. Okay, so if I were to pull up a calculator here, let's go ahead and pull it up. I will type into my calculator 220 meters divided by 25 seconds, and I get that my average speed is going to be 8.8 meters per second. Notice it is not the 10 that we got before. It is 8.8. And what that means, it means that if I traveled at 8.8 meters per second for 25 seconds, I would be at the same position. Now, we can simplify this, so instead of doing it in 3 steps, we can do it all in 1 step. And so I can say the average velocity equals the sum of all of my distances. So my delta x1 plus my delta x2 plus however many delta x's I have. And all of that divided by my delta t1 plus delta t2 plus ... all the time periods that I have from now on. So this is what we're going to use to calculate an object's average speed. So the first step is to determine the distance. The second step is to determine the time. And then the third step is then we can get the average velocity. Thank you. That's this lecture. Get started on your work.